Hey there, YouTubers! Lovely weather we're having. How's your day been going?
No, it's been rather up and down. Do you want a scoop?
No thanks. I quit sweets, but back in the day before I hit rock bottom, I used to enjoy all kinds of flavors like red and blue raspberry. What's your favorite flavor and color of ice cream?
You know, I like rather strange flavors of ice cream. I prefer them to have the color baby puke green.
Oh, charming.
You know what's been at the top of my mind lately? Quantum mechanics.
Well, that's an interesting quirk.
Phil, Swift here with Flexio, the rubberized sealants in the can. Oof, now that's a lot of damage. Just kidding, normal Phil here. Welcome back to another physics video. Today we're going to explore the basics of quantum mechanics, where I will wreak unfixable damage to your intuition of reality. This is also part 1 of part 2 of my multi-part series on energy. Or better yet, part 2.1.
Excuse me, sir. Did you drop this?
What do you mean by drop? Because in this mysterious world that we live in, everything is subjective and up to the observer. Except you.
Wait a minute. This is my show. Sorry about that. Dr. Sheep here. Now let's get back to our regularly scheduled program. Sorry about that. You let Phil write one script. He thinks he can rule the world. Anyway, we're going to break this video down into 3 parts. Now, normally we would do these videos in the studio. However, if you've ever watched a video on quantum mechanics, they're always in a studio of some sorts. Today I'm going to raise the bar to the outside world. Now let's begin by tunneling into what quantum and mechanics are. So we can break this down to 2 different points: quantum and mechanics. Quantum refers to the individual packets of energy, like a photon, that is proportional to the frequency of radiation it represents. I think the easiest way for people to think about particles and as waves and waves as particles is to think about photons. Photons are probably the most familiar quantum particles. If it has a large frequency, it has a larger energy and a smaller wavelength. Like blue light has a larger frequency than red light. It has more energy per photon. Now, mechanics is a branch of applied mathematics that focuses on studying motion and the forces that produce the motion. Energy is a property of matter like inertia and allows for work to be done, allowing forces to produce motion. All of that we've discussed in previous videos. Now, mechanics can be broken down into 2 different categories: classical and quantum. Classical deals with classic physics, meaning the particles are at rest or are moving significantly less than the speed of light. Quantum deals with particles that are moving at a larger percentage of the speed of light. And that's all for this section. On to the next one. Now, we've discussed how atoms produce light before on this channel, and we'll probably do it again in the future. But here's what you need to know now. Atoms typically exist in a state called ground. When hit with a specific amount of energy, the atom is excited and an electron is bumped up into a higher energy state for a non-zero lifetime. The lifetime for an electron in this excited state varies based on the atom or molecule, and it is probabilistic and can be calculated for Fermi's golden rule. This time is anywhere from a few nanoseconds to as long as 10 million years. The amount of energy released here is called a quantum of energy. This brings up the idea of quantum field theory, which this provides the theoretical framework of classical field theory, special relativity, and today's topic, quantum mechanics. This allows us to build physical models of subatomic particles and their interactions. Physicists use Feynman diagrams to illustrate these interactions. Now, there are more aspects of quantum mechanics than this, and are beyond my understanding or Phil's. So let's move on to something that I can
Why, hello there. I have my fun fact book. I'm in my fun fact chair. That means it's time for a fun fact. Today's fun fact has to do with the origins of quantum mechanics. Quantum mechanics was first proposed theoretically by Niels Bohr in the year 1900, where he came up with the theory of a quanta. The modern theory of quantum mechanics was later proposed by many scientists in the year 1925. Isn't that just fascinating? Yes! Oh, son of a...
Now that skit might not have made sense to the regular observer, but trust me, it will. This skit demonstrates the idea of quantum tunneling. Quantum tunneling brings up a lot of basic ideas really fast. I'm going to cover those now. The first is the Heisenberg uncertainty principle. This basically says that an electron or other subatomic particles' positions and momentums cannot be measured simultaneously. We call the state these particles are in, until measured, superpositions. This is best explained by Schrödinger's cat. The idea is that you put a cat with a vial of poisonous gas in a box. This box is connected to another box. And in this box, you have a radioactive sample, like this banana, and a detector. The detector will send a signal to the vial if it detects radioactivity from the nucleus of the sample. After shutting the box, you have no idea if the cat is dead or alive until you open the box. This is because radioactive decay is a truly random process. The cat can be thought of as in a superposition of dead and alive. Quantum tunneling marries these ideas together by saying that a certain mass of matter can appear on the other side of a barrier of a specific distance. The probability of that ball from the skit going through that wall was so low that the protons that make up the ball would decay, or the universe would reach maximum entropy before the ball would ever quantum tunnel through it. However, with electrons in the distances of a nanometer, electrons have a very high chance of going through the barrier. This is one of the biggest problems facing modern computers, where the size of the transistors are approaching these small distances. However, that's another video for another day. In the meantime, I would like to thank you all for watching. Please like, comment, and share. New videos every other Friday, 4:30 p.m. Central Time, and good night.
Subs for trees. Subs for trees. Subs for trees. Subs for trees. Oh, you're still here? I thought I told you to go home. Oh, you want more? I'm flattered. Check out the playlist. If you want exclusive content, check out my Instagram, Dr_sheep_YouTube. That's all lowercase. If you want to help the earth, subscribe. When I reach 100 subscribers, I'm going to plant 10 trees. If you feel that's too small, then check out my channel chart where I lay out even bigger goals. Finally, stick around for the next 20 seconds to give me that sweet watch time. Bye.